Hi guys, welcome back. Today I want to teach you how to use square and cube roots to solve basic variable equations that have exponents in them. So, you know the drill. Please make this the next title on your math notebook. When you've done that, mark that page, close it up, clear all those distractions away, turn everything around you off that might be distracting, get it out of the way, give me maximum brain power for just a few minutes so it's times are right, and we will get after it. All right, a couple things to remind you of first. First, square roots are the inverse operation of squaring. That's what we've been doing, right? So we kind of learned like 8 squared is 64. So the inverse operation of that 4 is 8. They're just inverse operations of each other. Cube roots are the inverse operation of cubing 2. So 5 cubed is 125, which means that the cube root of 125 is 5. So couldn't write the things to know. First, just a thing to know. I've briefly mentioned this, I know, in class a couple times, but positive numbers actually have 2 square roots. And I want to make sure we know that. So if we look at, say, I asked you for the square root, I'll just pick an easy number, like 25. You're like, oh, that's 5. 5 times 5 is 25. And it is. That's right. I'm not trying to say anything different about that. But there's actually another number. 5 times 5 is 25. That's why that's true. But actually, there's another number 2. Negative 5 is also a square root of 25 because negative 5 times negative 5 is also 25. So positive numbers actually have 2 square roots. And I know I've mentioned that a little bit. Hard to remember. Your calculator is like never going to tell you this. Calculators make math easier, but they don't necessarily do math for you entirely. And like if I do the square root of 25, it's only going to tell me the positive square root. I have to be smart enough to know, it actually has 2. So when we get to something like that, we just first of all think through like square roots and cube roots. So starting with that, square roots of positive numbers, roots, right? They're going to have the positive one and they're going to have the negative one. So square roots of positive numbers, there's actually 2 solutions. Square roots of negative numbers, well, what times itself is negative 25? It's not 5, because 5 times 5 is positive 25. And it's not negative 5 either, because negative 5 times negative 5 is also positive 25. So actually, negative numbers, there are no solutions. Negative numbers do not have a square root, so they don't have any. I could put like a 0 there. So that's something to know. Cube roots of positive numbers, that works out okay. A simple one, say, is 27. That's 3 times 3 times 3. The cube root of 27 is 3, because 3 times 3 times 3 is 27. It is not negative 3. There's only one. Because negative 3 times negative 3 times negative 3 actually is negative 27. So don't have it. So they have one solution. And cube roots of negative numbers, square roots, there are no solutions to a square root. Cube roots, you can. Because like I just said over here, turns out negative 3 times negative 3 times negative 3 is actually negative 27. So the cube root of negative 27 is negative 3. So it has 1 also. So that's just one of the things to get used to if you're not already with square and cube roots. Square roots, positive numbers have 2, negative numbers have none. Cube roots, positive numbers have 1. Negative numbers also have 1. So when you look at equations with variables in them, that's what I want to look at today. If you'll recall back to when we did basic equations like, say, this, I'll make it real easy. One of the strategies we used most often to find x was called the inverse operation strategy. And in that case, I would say to myself, what's happening to x? X has 5 being added to it. So the inverse of adding 5 is subtracting 5 to both sides. And that's how we would find the answer to that in a formal way. We'd say, okay, the inverse of adding is subtraction, so I do the inverse operation. Same thing now with an exponent. I look at my variable and I say, okay, what is happening to x? X is being squared. So I want to do the inverse of squaring it on both sides to figure out what x is. So the inverse operation of squaring is a square root. So if I take the square root of both sides, the square root of x squared is just x, because x times x is x squared. And the square root of 81 is 9. That's how you do that. Just like addition and subtraction are inverse operations, and multiplication and division are inverse operations, so is an exponent and a root. They're inverse operations. So down here, again, these are real clean ones. They're kind of easy to do. X to the third power equals negative 512. So I look here, I say, what is happening to my variable? It's being raised to the third power. The inverse operation of that is taking the cube root, third power, cube root. Those are inverse operations, so I do that on both sides. And I get that. Cube root 512 is a perfect square. It's going to have a negative answer. Which one is that? 5, 6, 7. Let me see if that's 7 to the third power. Can't remember. 7 times 7 times 7. No. How about 8 times 8 times 8? That's it. So negative 8. Cube root is negative 8. So that's on real simple ones. Or I shouldn't say simple, but ones where the answer comes out real clean. Actually, ones the same process, but I have to know enough math to know it's, I'm going to have to use a calculator to do it, frankly. Because when I look here, I say, okay, let's figure out what R is. Well, what's happening to R? It's being raised to the second power. It's being squared. So the inverse operation of that to solve for it is to take a square root. Then I'll just get R, the square root of R squared. Those are like opposite operations. They cancel out. And then I would take the square root of this side as well. So if R squared is 13, then whatever R is, it's going to be the square root of 13. I don't know the square root of 13. And it's going to be messy. So I've just got to look and say 13 square root, and it's that. I'm going to round it to, say, 2 decimal spots and leave it there. So sometimes you have to use a calculator to do it. X to the third power is 77. That is not a perfect cube. I don't know the number that times itself is there. I do know the process. If x is being raised to the third power, the inverse of that is the cube root. That'll just give me x. Inverse of that is the cube root. I do have a fancier calculator that'll do a cube root. So I use this Desmos one. Here, if I do this, and it said, then I can put what root I want. Cube root of 77 is, again, messy. I don't know that perfect cube, so it's a long, messy answer. I'll round it to 2 spots, say 4.25. And there we go. And sometimes there's no solution, right? A squared equals negative 25. What times itself is negative 25? Nothing. I can't multiply something by itself and get that. I can write down the steps. Say the inverse operation of squaring is square root, a, but there is no square root of 25. So there's just no solution to that. There is no number that a can be to give you that. What if there's more steps in the equation, like this? So you remember when we did other ones that had multiple steps, the way we knew what order to do the steps in is we did the old GEMS order of operation backwards. So when I look at this one, I'm going to do subtract and add here before I do the exponent here. So my first step, x has 12 being subtracted, so I will add 12 to both sides. Negative 12 and 12 make 0. That's why we do that. So x squared would equal to 100. Now I've done the subtract and add. Now I do the exponent one. So x is being squared. The inverse operation is square root. And I would get x equals 10. And if you go back here and check, it works out. 10 squared is 100 minus 12 is 88. Check, smiley face. Yay. Same thing here, same steps, right? I'm going to do subtract and add first, exponent second. So subtract 10 from both sides, or add negative 10 to both sides if you prefer. Those cancel, you get x to the third power equals negative 27. Next step, now I've done this, exponent next, x to the third power, the inverse operation is cube root. And x equals, the cube root of negative 27 is negative 3, I happen to know. If you don't know, you can always use your calculator to do that. All right, so let's do that. First thing, I just want you to write down to know, positive numbers actually have 2 square roots, super important. And it's only square roots, not cube. But write that down for me. Things to know, positive numbers actually have 2 square roots. So if you're going to go find the square root of 36, it's positive 6 and it's negative 6. There's 2 different numbers that the square root of 36 could be. And I want to make sure you know that. Pause here, write that down, and I would also make note. Your trusty calculator will probably not tell you that. I have seen some super fancy calculators that if you put in square root of 36, they'll show it like this, which means it can be positive 6 or it can be negative 6. Kind of a weird looking symbol. That's what that means if you ever see it. So let's just do a few quick examples of solving equations that have a variable in them here. You can pause or write them down. The key here to know is that a root is the inverse operation of an exponent. So if x is being raised to the 3rd power, the inverse operation of that is cube root. That's going to leave us with x. And the cube root of 125 is negative 5. Negative 5 times negative 5 times negative 5. Same thing here. If w squared equals 80, the square root is the inverse operation. If I take the square root of w squared, that just gives me the w. Inverse operation. Square root of 80, I do not know. It's going to be a messy one. It is. It's a little less than 9. Oh, because 81, it would have been 9. So 80 is a teeny bit less. 8.94. I'll do squiggly about 8.944. Negative 36 equals y squared. Square root will tell me y equals whatever the square root of negative 36 is. Uh-oh. No solution. There is negative numbers don't have a square root. They do have a cube root. No square root. There is no number that times itself will be that. Okay. Last but not least, what if there's 2 steps to do? Here I've got to multiply and I've got an exponent. How do I know which one to do first? Do I square root first or do I divide by 5 first? Well, remember, the way to remember that is you do gems in the other order. So we don't have that, we do have that, and we do have that. So I'm going to deal with the multiply and divide first. So x is being multiplied by 5. Inverse of that is divide by 5, which is weird. We usually do that last in all the equations we've done before. But we deal with that first and that second in this case. So that's going to be 1. That just leaves me with the x squared, or 1x squared. 45 divided by 5 equals 9. Now I've done that, so next I deal with the exponents. So square root, inverse operation of squared is square root. Careful here, x equals the square root of 9, there are 2. So in this case we would say x equals 3 or x equals negative 3. And that, my friends, is how you solve variable equations that have exponents in them using square roots or cube roots. I hope this made so much sense to you. If it did, wonderful. If it did not, give it a second watch and I promise that'll help. I know I have to sometimes go fast. I'm up against the clock and it's new. And a lot of times just hearing me say all this a second time, you'll hear it through and be like, that makes perfect sense. I got it. So that's it, y'all. When you're ready, I will see you tomorrow. Bye.